Hello everyone, it's the Math Fizz Wiz here, and I'm here today with a new video on a very common problem in physics, and that is throwing a ball, which is often known as projectile motion. So, the first type of these problems that we're going to examine is throwing a ball vertically into the air, just like the man who is standing here. These problems are problems in which acceleration exists. That is because when we throw a ball up into the air, it goes up until a certain point and then it starts falling down. We have an acceleration here, which is due to the force of the gravity of the Earth, and an acceleration which is equal to g, and g is often known to be near 10 meter on second square. Therefore, because acceleration exists in these problems, we use the formulas regarding problems which have constant acceleration. And these two formulas are the two major ones which will help us solve almost any problems in throwing balls vertically up into the air. Using these two formulas, I'll now solve an example question. So the example is this. A ball is thrown up with a speed of 10 meters per second. How long does it take for it to get back? Okay, so we know that the initial speed of the ball is 10 meters per second. We know the acceleration, which is given to us as 10 meters on second squared. But because the speed is upwards and the acceleration is downwards, we have to use a negative acceleration. So in this case, our acceleration will be minus 10 meters per square second. So this will be our acceleration, and then we have to use one of the formulas. But which one of these two should we use? We have to see what the question wants from us. So what it wants is the time that it takes for the ball to get back. So we're looking for t. Therefore, we have to use the first formula here, which is x equals the initial position of the ball plus the time times the initial speed, which is 10, plus half of the square of time times the acceleration, which in this case is minus 10. So this is the equation we're looking for. But what should we put instead of the initial x? This is something we can choose arbitrarily, and it is often good and easier to use the initial position of the ball as 0. This way our calculations will be much easier. So this is x0 equals 0. So therefore, our equation will turn into this one. X equals 10 times t plus t2 times minus 5. This is a second order equation, which has two answers. But why is that? Because for each place along the y-axis, we have two times for which the ball has been there. Because first the ball will go up until it reaches its peak, and then it starts falling down. So therefore, if we're looking for the time that the ball reaches a certain height, like h, there will be 2 points in time for which this has happened. And therefore, our equation is a second order equation. And in our case, the ball has been in position 0 at time 0. And therefore, one of the roots of this polynomial is t equals 0. So we have x equals t times 10 minus 5t. So we're looking for the times in which the ball has been in position 0. So we put 0 instead of x. 0 equals 10 times t times 10 minus 5t. And this will provide us with two answers to t. One of them is t equals 0, which is the base case for which we know. And the other one is t equals 2 seconds. And this is the answer which we were looking for. And therefore, we've solved this equation, this question, using one of the provided equations. The second case of these problems is throwing a ball with an angle. And these problems are often called 2D projectile motion problems. What are these problems? In these problems, we throw the ball with an angle to the ground. We don't throw it up vertically. And therefore, the ball will go up until a certain point, and then it starts falling back down, and in the meantime, it's going forward until it hits the ground again. And that's when we stop the question, because we are not concerned with what happens after that. That's a more complex version of physics. But how do we solve these problems? The key point in solving these problems is this. This is very, very, very important. We have to project the velocity vector into a horizontal vector and a vertical vector. But how do we do that? When given the initial velocity and the initial angle, we're actually faced with a velocity vector, which is the one in red here. If we show its magnitude this way, we can do the projecting using the following formulas. So we can write the initial velocity or the initial speed in the y direction equals v times the sine of theta. And also the initial velocity in the x direction or in the horizontal direction equals v times the cosine of theta. Now that we have this, our problem gets much easier because it's actually now divided into two simple problems. One of which is concerned with throwing the ball vertically with an acceleration of g, and the other one is concerned with the horizontal movement of the ball with an acceleration of 0, which makes things much easier. Now, when we're given a problem like this, if the problem asks us about how long does it take for the ball to reach the ground again, we have to deal with the vertical vector, because that's what determines how long the ball takes to go up and then back down again. And if we're asked about how far the ball goes, we're then faced with a problem regarding the horizontal vector. Now, if I want to deal with the vertical vector, we have the same two equations we had before. It's regarding the vertical movement of the ball. And if we want to deal with the horizontal movement, we have a new and simple equation which does not have any acceleration involved, because the horizontal movement does not have any acceleration. And this is because there is no force in the horizontal direction to the ball. Now, let's solve an example question here. The example is asking us how far does the ball go when thrown this way. So, the ball is thrown with an angle of 30 degrees and initial speed of 20 meters per second. Now, the first thing, as I mentioned before, we have to do in these problems is to project the vectors. So, we will now do the projection. We have the initial speed in the y direction equals 20 times the sine of 30 degrees, which will equal 10 meters per second. And then the initial speed in the x direction equals 20 times the cosine of 30 degrees, which equals 20 times the square root of 3 on 2, which will be 10 times the square root of 3 meters per second. Now, the question is asking us about how far the ball goes. Therefore, we have to use this equation, as I explained. So we have x equals x0 plus 10 times the square root of 3 times t. Now, as I said before, it's easier for us to always choose the initial position of the ball as 0. So x0 will be equal to 0, and we will have x equals t times 10 times the square root of 3. But now we're faced with another problem. T is unknown. And what do we do about that? Therefore, based on my explanations, we have to use the vertical vector to calculate the time. Therefore, we have to use this equation again. We have y equals y0 plus the initial speed times t plus half of the acceleration times t to the power of 2. And again, we choose y0 to be equal to 0. We have the initial speed equal to 10 because we're now dealing with the initial speed in the y direction, which is 10 meters per second. And we have a as minus 10, as described in the previous question. So we can rewrite the equation as y equals 10 times t minus 5 times t2, which again will provide us with two answers. The first one is t equals 0. We don't have to deal with this because it's the initial position, so we don't want this. What we want is the second root of this polynomial. So therefore, we have to set t times 10 minus 5t equal to 0, which will provide us with t equals 2 seconds again. Now that we have the time, we have to insert it into the equation we had before. So we have x equals t times 10 times the square root of 3. And now that we have t equals 2 seconds, x will be equal to 20 times the square root of 3. And this is the answer to this question. I hope you have enjoyed this video, and I hope that you've learned something from it. Please comment if you have any other questions in physics and math, and I'll be happy to make a video to help you regarding your problems. Thank you, and see you in the next video.